Okay, today we're going to look at volume of revolution of functions. So the idea is if you have a function f of x, which is equal to y, and if this function gets spun around the x-axis, it's going to create some sort of a cone or a horn or some sort of a volume of revolution. And we're going to use calculus, we're going to use integration as a tool to find the volume. Much like we've learned how to multiply and how to divide numbers, and then we're shown volume formulas and area formulas, and we can find the volume of cylinders and area of rectangles by using multiplication. It's the same idea. We're going to use integration as a tool to find the volume of revolution of a solid. So just to take a look at this terminology, this is going to be read as pi times the integral from a to b of y squared. And to break this down, it's your bounds of integration are a to b. That's the starting and the stopping point of the volume of revolution. And this solid can be broken up into an infinite amount of circles or infinite amount of cylinders. And each cylinder has a base, which is a circle, and the area of a circle is pi r squared, and every cylinder has a height, a delta x. So that's the dx. So this is our calculus notation for finding the sum of an infinite number of cylinders that add up to the volume of revolution. And we're going to be using this formula that the volume of revolution is the area of the base, which is pi r squared. We have a start, we have a stop, and times the height of each cylinder, which is dx, or our delta x. So it's pi times the integral of a to b of the function squared with respect to x. So if we perform this formula, we'll get the volume of revolution. And I'm going to show specifically how to do this on the calculator. Our instructions say to use technology to find, correct to 3 significant figures, the volume of the solid of revolution formed by these two functions. So we'll start off with A. And on the calculator, you begin by entering the equation into y equals. So to have a fraction, I'm going to do alpha y equals and get my numerator denominator. I have x cubed divided by x squared plus 1. That's our function. I'm going to graph it to see what it looks like. Oh, this is a slow graph. So we're essentially getting our function, and we're going to cut it from 1 to 3, spin it around the x-axis, and find that solid. And to do that, we'll go back to our home screen and just essentially remember our formula as we do this. And we're going to type in pi, and then if we hit the math button, we can go to the integral, and our bounds of integration are 1 to 3. Our function, it's already entered in y1, so to bring that up, I'm going to hit alpha trace, or alpha F4, and select my y1. So it's pi times the integral of a to b of y squared, and this is important to square the function, and we're doing this with respect to x, and you hit enter. So your answer is 18.6. That's the answer to 3 significant figures. Write this down. So this first answer is 18.6 units cubed. Okay, and taking a look at the second one, we'll do a very similar strategy. I'm just going to go type in pi. I'll have to enter the function first, I'm sorry. So let's enter our function of e raised to the sine x. We can graph it. and we're going to get this volume from 0 to 2. So quit, go here, I'm going to type in pi, and I have my integral from 0 to 2 alpha trace y squared with respect to x, and our answer is 30.19. So to 3 significant figures, it would be 30.2. So we have, oh come on pen, 30.2 units cubed. Okay, all right, so there's our formula and some practice problems for volume of revolution. This is Mr. Martinez. Thank you for watching.